Hi guys, and welcome back to this journey towards excellent exam results. In these shorter revision videos, we are going to be breaking down different concepts within the GCSE Geography specification. The aim of this is to help us understand the concepts better and to give us the information and confidence we need to answer exam questions. In today's video, we are going to be discussing how geology, tectonics, and glaciation have shaped UK landscape. Okay, let's get started. So this slide here shows a picture of Malham Cove, which is an upland landscape in the Yorkshire Pennines. Now this was once a very huge waterfall here in the UK, and as you can see from the picture, it's quite high. So at 80 meters high, which is 30 meters higher than Niagara Falls. Now it's mainly formed from limestone, and it contains shells of corals that lived in tropical seas over 300 million years ago. So the question is, how did it end up 300 meters above sea level right now when it was originally beneath the sea or beneath the oceans? So one of the explanations here that we can give for why we have an upland landscape that was once under the sea is that the UK was once covered by tropical seas. That was around 300 million years ago, and that period is normally referred to as the Carboniferous period. So it was almost like, the Great Barrier Reef of Australia. And as the fish died that lived in the seas, they obviously fell to the ocean floor, and together with the deposited sediment, they formed horizontal layers of sedimentary rock, and which obviously is referred to as Carboniferous limestone. So the layers, however, will vary in hardness, and the most resistant of these layers is the Millstone Grit, which forms the highest peaks in the Pennines and will protect the sands and the shells beneath. Now, as you can see here in this cross section here that is on the slide, the Millstone Grit is the one right at the top here, and that obviously is the most resistant. And then we go on to the shells and the sands below, and those ones are less resistant and have eroded faster. Okay, now we will come on to explain why the rest of this particular cross section looks the way it is as we go along. But as you can see, there's this line here that is going across that shows the height of the valley before the Ice Age. And so it looks like the Ice Age did make a lot of changes, and we'll see that as we go along. So the rocks in the Pennines have been affected by three main tectonic processes. The first one is continental drift. Now we know that that theory of continental drift suggests that continents tend to drift away from each other or towards each other because of convection currents that are acting underneath them or at work beneath them. So the continental drift meant that the plate on which the UK sits moved away from the tropics and ended up in the mid-latitudes where we are at around 58 to 60 degrees north of the equator. And then the second process, tectonic process, was uplift. So we know that as plates move as well, they can tend to be pushed upwards, and this is what happened in this case. And the Carboniferous limestone rock that was below the sea was pushed upwards to form land. So instead of it being under the sea, it was pushed upwards and is now above the sea level. And then thirdly, faulting also took place, which is another tectonic process. And some of the rocks snapped as the uplift was taking place. And this formed steep edges, which are known as fault scarps. Now, Gigglewick's Scar in the picture here is an example of that faulting that led to those fault scarps. And as you can see here, there's a very, very steep scarp slope right here that drops down right to the bottom of this particular valley here. So this here is an example of the faulting that took place. So three tectonic processes: continental drift, uplift, and faulting. So as the Pennines were uplifted, drainage basins were created. Now, on every kind of upland landscape that you have, you're likely to have a drainage basin, which is draining water from the landscape around it. And especially because it's an upland landscape, there's the force and the pull of gravity, obviously, that is causing the water to flow down, the landscape towards what you can see here as in the form of a V-shaped valley. Now, the water obviously is flowing either through surface runoff, through flow, groundwater flow, and so on, and ending up in the bottom of this river valley here, which is in a V shape. However, this kind of shape of a river valley was then changed and transformed by glaciation, which is a process that took place here in the UK around 10,000 years ago. Now, we know that the Earth experiences glacial periods as well as interglacial periods. So the interglacials are the warmer periods, and then the glacial periods are the colder periods, where we have a lot of ice sheets that are moving across the landscape. And that is what happened here in the UK around 10,000 years ago. And these V-shaped valleys, due to the ice age, were then deepened and widened. And that eventually formed this U-shaped valley that you can see in this other picture here. And you can also see that again on this cross section here of the Wharfdale, in the Pennines. So glaciation also had a big role to play in the shaping of the landscape of the Pennines because it transformed or changed V-shaped valleys into U-shaped valleys. That brings us to the end of this video on the influence of geology, tectonics, and glaciation on UK landscape. I hope that you have found the information insightful and useful. I have also put together videos on all the other subtopics within the UK's evolving physical landscapes topic. 2 of them will pop up as suggested videos at the end of this one, and the rest will be in the UK's evolving physical landscapes playlist. Thanks once again for joining in this journey towards excellent exam results. All the best and see you again soon. Bye-bye.